Hey everyone, how's it going? Welcome back to another video. And today we'll be looking at this problem that is called island perimeter. And this problem has already been covered in a few other videos that I've seen on YouTube, and there's quite a few other videos covering how to solve this problem. But I felt like I had a simpler approach, which was a lot simpler to implement and usually ran a little faster than the other DFS approaches. So I'll be covering that in this video. So let's first understand what the problem says. So we are given a map in the form of a two-dimensional integer grid, where 1 represents land and 0 represents water. Grid cells are connected horizontally and vertically, and the grid is completely surrounded by water. And there is exactly one island. The island doesn't have lakes, and one cell is a square with a side of length 1. The grid is rectangular, width and height don't exceed 100, and you have to determine the perimeter of the given island, right? So your usual DFS approaches simply start off at one of the land areas and just simply DFS down the entire island and simply return back a result. What we'll be doing is we'll be following a similar kind of approach, but we won't be performing a DFS per se. We'll actually be looking at all the cells individually. So what we'll be doing is, the first thing that we need to notice for our approach is that when do you add, let's say, a unit to the perimeter or to the result, right? When do you add 1 unit of length to the result? Let's see when that happens. The first condition for that is that we need to be on a land area, right? We need to be on a land cell. So we need to be on any one of these brown cells, right? Which represent land. Now, the number of units of length you'll add to your perimeter will be directly equal to the number of sides of the island that are touching a water body or are touching the edge of the grid. So what do I mean by that? So let's say we look at this particular cell right here at the position 0, 1. We add 2 to the perimeter due to these two water bodies on the left and the right, and 1 to the perimeter because one of the sides touches the edge of a grid, right? Similarly, looking at this cell right here, we add 2 to the perimeter, 3 to the perimeter. We add 3 to the perimeter because of 3 sides that are touching water, right? There's the top part, there's the right hand side part, and there's the bottom part. Similarly, if you look at this particular cell right here, you'll see that you add 2 to the perimeter because 2 of its sides are touching water. Similarly, if you look at this particular cell, you add 2 to the perimeter because one side is touching the water and one side is touching the edge of the grid. So we know that there's mainly 2 kinds of conditions where you will be adding a unit of length to the perimeter, and that is, one of them is either the one portion or one side of that particular cell should either be connected to the edge of the grid, or that particular side should be connected to a water body, right? So we need these 2 conditions, and either of them can be true, and we need to check that for each side of the cell. We need to check these conditions, that if that side of that particular cell is either connected to water or to the edge of the grid, and we need to check this condition for every side of each cell, for all the 4 sides of each of the cells, right? So for this cell, you'll be checking this condition for all the 4 sides, which is left, right, top, and down, and similarly for all the other cells, right? So how do we implement this? The implementation is really simple. All you really need to do is simply iterate through the entire grid for int I equal to 0, and while I is smaller than grid dot size plus plus I. Now you'll iterate over the columns, so you'll just write for int j equal to 0 while j is smaller than grid of 0 dot size, which is basically the number of columns, plus plus j. Now you need to check if the current element or the current cell that you are scanning, if that's a land cell, because we'll be performing these checks only when we are encountering a land cell. So we'll just check if grid of I comma j. We just need to write this because this will give you a true result, and you'll enter the if condition. If this value is 1 and if it's 0, it will automatically equate to false, right? So similarly, now we need to check if we need to check for each of these sides of this particular cell, right? If they are connected to water or to the edge of the grid. And we need to keep track of the parameter as well. So we'll just create a variable for that real quick. We'll just call this int sum, or let's call it int parameter rather, right? And we'll initialize that with 0. Now, what you need to do is you need to check for each of these conditions of the cell touching the water or touching the grid. So you'll simply write, and for each of those conditions, you will be adding 1 unit of length to the parameter. So you'll just write parameter plus equal to. Let's first check if the side of a cell, if the top portion of the cell, let's say, which is this portion of the cell or this portion of the cell, if this portion or this side of the cell, the top side of the cell touches the edge of the grid or a water body. So to do that, the first condition will be if I equal to 0. This will give you a 1 or a true result when when this cell is touching the top edge of the grid. Or if this is not the case, if it is not on the top edge of the grid, it is somewhere inside, on the inner portion of the grid, you'll simply check if the grid I-1, that is the cell above the current cell, comma j, the current column itself, equal to 0. So you're just checking if either the the cell above the current cell is either it is the edge of the grid or it is a cell that contains water. So this entire expression will evaluate to 1 if either of these two conditions is true, and will evaluate to 0 if none of them are true, right? So plus, now we'll check if this cell touches the bottom edge of the grid or the bottom portion of the cell touches any water body, right? So we'll simply write I equal to grid.size -1, which is the last row. If this is true, that it will mean that the lower portion or the lower side of the cell is touching the edge of the grid. If this is not true, then we'll check if the cell below this current cell contains water. So to do that, we'll simply write grid I +1, the row below the current row, and j, which is the same column, equal to 0, right? So you've written that. Now, what do you want to check? We've checked the top side of the cell. We've checked the bottom side of the cell. Now we need to check the left and the right hand side. So for that, we'll be checking j. So we'll write plus if j is equal to 0. If the left hand side of the current cell touches the left edge of the grid, then the j will be 0. Or if it's somewhere inside the grid, we'll check if the cell on the left of the current cell is made up of water. So we'll just write grid I, j -1, which is the same row, but the column to the left, if that is equal to 0, right? Then you'll add 1 if either of these conditions is true. Plus, you'll simply check j equal to grid 0.size -1. This is basically the last, this is basically the condition if the right hand side of the current cell touches the rightmost edge of your grid, right? If that is the case, then you'll add 1 to the parameter. If that is not the case, you'll also check if the cell to the right of the current cell is made up of water. So to do that, you'll just write grid I j +1 equal to 0. And this basically checks all the possible conditions when you need to add something to the parameter, right? So you just checked if the top portion is connected to the parameter or to a water body. You just checked if the lower edge of the current cell touches the edge of the grid or a water body. Similarly, you checked if the left edge of the current cell touches either the edge of the grid or a water body. And finally, you checked if the right edge of the current cell touches the right edge of the grid or some other water body, right? So that is all the conditions that you need to check, and this will simply add up the parameter after iterating through the entire grid, and all you need to do in the end is return the answer. So let's run this code and let's check if it runs. And it does. It gives us the correct answer. So we'll submit this, and this does get accepted. And that is basically how you solve this problem. And here it says that it took 236 milliseconds, but usually it takes around something like 152 or 108 milliseconds. So these timings just keep on differing, but this gives you the correct answer, and you get a really nice memory usage as well, because you don't have to keep track of any of the stack frames that are there in DFS, right? So this is how you solve this problem. And if you like this video, hit the like button. If you want to see more content, just subscribe to the channel, and I will see you in the next one.